Hello, welcome back to our CSCI 310 cybersecurity. Okay, for today we'll continue about related to the network, security, and this time we will move on to another part will be related to our network segmentation. Okay, so about the segmentation, so we need to have some like basic idea. So what's the segmenting the network? Okay, so including some like physical or logical or the virtual segmentation. That means maybe through the devices, like actually physically, we can do the segmenting like by the device, or something like logically we can using the VLAN, okay, virtual LAN, or some like virtual network, so they will can perform the segmentation. Okay, so of course we need to consider the performance. Like if we have some like high bandwidth application, then how can we enhance the performance? Okay, and when we try to apply it, okay, then how can we ensure the security? Okay, how can we apply it? Okay, we are not allowing the user to directly talk to the database server, okay, but they are only some like applications like in the core, let's say the SQL SSH, so they can access it, or something we can go through the middleware or proxy, then we can access to the database, okay, and also the components. So what the post-implemented like segmentation, we are going to apply like the PCI, okay, so all this will be going covered. And physically, so the devices can be separated by the switch. Like let's say we have the switch A, B, C. So all these like we really actually switch those network. Okay, so this physically, that's how we do. And then they are must connected to provide the communication. So they are directly like connected together, or other switch or some router, they are like connect to each other. So it's physically we have the cable like connected together. Or sometimes we have the web server. If you the we have the web servers, we have the just put them in together in one rack. Okay, so maybe we have another like database server in another rack, so they would and then you can like connect them together using the switch or and then router. Okay, and if we talk about that the situation, if we have a customer, okay, so there's a customer on one switch and then the customer B and then on another switch, so they are kind of physically like segmented. Okay, um the advantage and then the benefits is there are no opportunity like for mixing their data, so this advantage. And here's the graph showing if we have the two networks and then we have the devices belongs to network A, and then it has its own router switch. So we can have multiple units, okay, under this. So they have a separate devices, okay. And then also they can have their own infrastructure. So they have multiple units, and then their infrastructure can be separate. Okay, so they are not mixing together. And for the logical segmentation, so we go about the virtual local area network. So we call the VLAN. Okay, so this one is kind of like separately, like we call it as a logically instead of physically. That means we have only one router or one switch right here. And then based on this device, we are going to using the router, okay, to separate it like kind of like by the setting. So it's like logical separate them. So they cannot communicate between the VLAN. So without the layer 3 router. So when you see the layer 3, because if we remember the layer 7 application and goes down right to the level 1 will be the really the physical, and then goes up like data link. So all this, and then for um, router level 3 router, then we can let the VLAN like to communicate to each other. So this one, like they usually they kind of like connect together physically, but we set up the virtual LAN. Okay, so the virtual LAN can help us to segmenting the this the two network. And for the virtualization, when you see, so they are not like more physical devices, okay, and kind of like that, and when we try to define, of course, we do have some like server, switch, router, firewall, load balancer, all these. So they all apply for all like virtual device too. So we can say it's a software defined network, okay, like this, and then with the instant and complete control. So we can like build or rearrange the network on fly, so it's really okay. And then we can drag and drop device between the networks, okay, or sometimes we can create new routes. And also we can drop in a firewall, okay, here, there, so we can change the virtual LAN. So here's the possibility. So when we apply, okay, and then we talk about the virtualization. Then we have the called air gaps. Okay, the air gaps will including the network separation, so they are not connected in any way. Okay, also mainly for some industrial system. Okay, the SCI, DA, or like manufacturing. So all these they are totally separate. Okay, so they are not connected, and also it can help to secure the whole networks. Okay, and they try to remove any connectivity between all the devices. So no way, okay, for one device to communicate with others. So they are not sharing any resources together. And we do have some technology, okay, can like jump the gap. So it's possible. Let's say we try to put a removable media. So the stanness, so the virus just like jump the air gap. So in error like using the USB thumb drive. So when you know the long time even right now we still have a USB drive. Let's say if we pop in and then we try to invert the USB. Okay, so invert the USB when it plug in into another computer, especially they're completely we call the isolated. That means we have the air gap like between those for that device. But because it physically connect to the USB, and sometimes when the USB is being like injected, okay, so those like malware can detect, okay, it's detected, and then I will copy itself, like code itself to the device, connected device, then also it's possible. So here will be called the total network isolation. We talk about the air gap. So like we have the network A, and then this completely this device like just like alone by itself, and we call the air gap. So it's right here. So it can prevent the intruders access. So we have no way unless we physically access to this device. Okay, so it increases the difficulty, but for more like sensitive, more important, secure data information, or have to running application have to run on this type of like a device, then we need to like implement some air gap. Okay, and then when we can move on, we have some like secure network protocol. Okay, so like physically, then we have the one, if you remember, we talked about the DMZ. Okay, the administrative zone. Okay, so this one is the additional layer of the security. So it's like between the internet. Okay, so and you, so maybe we have the public access to the public resources, right? So we can go and access it to the internet. So maybe we are not using on the organization internet network. Okay, so it would be like this, and then we have the DMZ, and we have another term that we talk about as the internet. Sometimes we have the extranet. Okay, and for the extranet would be like we talk about private network for partner. Okay, so they can be maybe we have some like remote vendors, suppliers they need to access. Okay, so we need to let them to connect, or we have to as a we need to access to the remote network, so we can have some additional authentication. So the one we heard a lot, so it's a VPN. Okay, so after we have a VPN, then we can like getting access to those network. Okay, and it can enhance the security. And after we talk about the extranet, then we do have an intranet. Okay, so this one is more like it's an internal private network. Okay, so mainly will be the employee only. So they are sharing business computer resources. So you see right here the differences. If we talk about the intranet, so is inside. So maybe they will access to the one or a server. Okay, data server, wherever. Okay, but for the extranet. So you will see it's really divided by the firewall, and then we have the server, like internal server, but we have the remote window supplier they need to access, so they can use the VPN to access it, okay, to each other. So still open, depends on the configuration, okay, so we can access when they can access to the your network, or if you need to access to your supplier, then you have to set up another VPN, okay. And we do have the we talk about the extranet, intranet, like physical connected, and then we have the wireless connection, so the wireless networking. So it's more like the convenient nowadays. Like most of devices nowadays we're using will know why. Okay, so just like connect. So mainly Wi-Fi. Okay, of course, more than Wi-Fi, and we do have security concern. Like maybe some of them they open for guests or no password, or like sometimes they giving a easy password. So some people they are or expect for some like public one. So anyone can hop on. So like this we need to make it separately, like maybe for internal use, then we have to configure a separate wireless network for the guest, right? Okay, like this. And then also the user can like add the authenticate to the user network. So normally we can use the just normal network login credentials, and we can follow the HO2.1x standards, and also we can integrate into like some existing service, and there's no wireless passphrase. Okay, so it's like always a share and widely known. So this one is the idea. Okay, and you see right here from here, just like in just telling you what's the Wi-Fi password. And if you go to, let's say, some restaurant, they're open for guests, or like if go to some store, they asking you to maybe type in the passcode, okay, for one-time passcode, or they will redirect to a login, like, or just some agree page or web page, right? So all this they have a risk, okay, so you can hack into this system or pretend man in the middle attack, okay. And also we have the guest network. So this like kind of like optional network. If you have your own router, you can configure it, okay. You can say allow for guests, okay. So this one can be give us a really convenience way to provide for sometimes for meetings or some like demonstration, or just like for short-term use, okay, because they expire, okay, they'll kick off. So there's no way to access to the internal network. So that's why it's being like separate. So we can like wall off, okay, from the corporate resources, okay. So we are mainly for the like internet access only. Let's say for maybe for restaurant, okay, they want to have some internal use. Of course, they have a Wi-Fi, but they want to allow the guests to use their internet, okay. But for internet access only, they don't want to let the guests to access any devices. Then you can create a guest network. Also, we can integrate with some like captive like portal, so we can avoid some unauthorized use of network. Also, we can put it using some like constrained area. Also, we can keep an employee of like the guest network. Okay, so maybe limit the support. Okay, so let's say okay, I can't print, I can't access, somehow like this. So it's like way better. Okay, and we also have another one called ad hoc. Okay, so this one is the wireless without an access point. So it's mainly on the mobile device. And mainly if you see the Apple, and we have the AirDrops or sometimes shared by Bluetooth, all these, so they are like contact sharing apps, all these can be using ad hoc. Okay, so it's difficult to control on a unmanaged device. So sometimes they will disable the ad hoc setting on the mobile device management. Also, we can implement some like network access control. So only like possible to use the ad hoc only with the right app credential. Also, we can limit the application used for ad hoc, like this. So they are all possible. And then we have the another one's called the honey portal, or like the honeynet. Okay, so this one is like there's a tempting target for the malicious user. So maybe checking like who are the possible machine, or make some like interesting beacon. So like this, okay. So why are they trying to connect in right now like this? Okay. So this one like the honeypot. So this one is like for the single use or for some like single system threat. Okay. And after we create all this, like we have multiple honeypots on a single network, then it create the honey nets. Okay, so maybe we have more than one source of the information, because we just like combine all this the for single use or single system. So all this like form a honey net together. And then we have the move on. Then we need to learn something about the network address translation. Okay, and sometimes you see the NAT, okay, so this one is about, so this one is pretty long time ago. So it talk about the IPv4. It can support like 4.29 billion address, right? But nowadays, it's already exhausted, so maybe no more address available. Okay, so nowadays, so then we're going to introduce the IPv6, but like for another things we do have to talk about that, how it works, like about IPv4. We also have network address translation. So the router, they will act like the surrogate, okay, and for public internet by traffic. So then it will translate each package between the public and private network address. So it can help. So that's like what the function of router. So for net, okay, so it's not really a security mechanism. Okay, just bear in mind. So it's not really helping for that. For this one, we need to think about, because this one the security through the offset security. Okay, so this one we need to be careful, because like for this premise, like if you cannot see it, then you cannot attack it. So here's the idea. And but so far this like is no security at all. So that's why. Okay, so for the malicious user, they can circumvent like and some protected net. Okay, so it can sophisticate some like attack. So assume like the net is in use. Also, they can try to gain some access to the internal device. So even though it with the net in place, so here's the idea: is that net is not really provide any security issue. Okay, it's just telling you, okay, for right here we just emphasize for the address translation only. Okay, translate between public and private. So we just assuming, okay, it does exist, helping to translate, and they say okay. So that's why maybe we need to have a firewall. Like sometimes we have a stateful. If you remember, we talked the firewall. So we have the stateful the firewall, so it can be the security mechanism applied, so it can use in the conjunction with the net to provide security. So here's the idea. Okay, and we keep on moving on. Then we have the network access control. Okay, so the next we see the NAS. Okay, so this one, it can protect the network from malicious host. So we are based on the standard like 802.1x. This one, okay, there's a standard, and the system must be properly configured before they allow on the network. Okay, so we can use for, okay, so using beyond networks. Okay, so this one can use like for some like standalone network applications. Okay, so we can apply kind of like inline. Okay, appliance inline, out of band, so switch base. Okay, so maybe we need to like switch the network. Okay, based on some decision or like some endpoint base. So for some host or computer can translate to the self access. So all these can use it for the network access control. And when we need to do the access control, we have some like basic exchange, including that we call the access requester, so the AR. So will be the device that request access to the network. So if you have a device need to request the access, then we can call the AR. So the access must happen. So either by the host or other system, they will check like are they allowed to access it. Then we have the policy decision point, the PDP. So this one will be like a device that like assess a policy like based on the assessment. So it would determine, okay, what access should be grant. Okay, so like this, and then also we have the PEP, the policy enforcement point. So will be the device like that, like if they need to create some like policy determination. So either maybe the switch, router, firewall, all this can carry the policy like determination. And also it can grant the access and also deny the access. So here's the enforcement point. Okay, so will be right here for the basic action AR, PDP, and PEP. Okay, and keep going. So let's say we say that AR, right? So with that access requested. So I have a host. So I say I'm new here. I want to join the network. So I say hey, and then we have the enable switch. Okay, NAC enable switch, and then we have the applicants. Okay, right here. So okay, so if they want to join it, they want to okay, I want to join it, and then they say okay, then we move on. Let me check, and then it's going to check. Okay, just stand by, and they say okay. They will ask okay, this want to get the access. The applicants right here. Okay, I want to get it. Okay, can I join this network? And then we have the maybe a different way to check, like let's say we have the PDP. Okay, so we see, okay, we scan it. Okay, so if you remember our PDP is the decision point. If you remember, like this one, we'll see, okay, if they have the assigned policy. So based on the assessment, so it's going to check, okay, so can it join it to the network, and after scanning, so it may be say yes or no, and then okay, so it wants to say okay, it's clear, so it's okay, then just this host can join it. Okay, and then it will say okay, assign the IP address. Okay, and then just like assign, okay, telling which is the gateway, so this one is the switch, so telling is the PEP. Okay, so it's the informant and enforcement like point. So PEP like return back. So this one is the gateway. So from the PDP and then PEP. Okay, so it will be like this. And like just like go back to here, if like we going to scan and then we have the decision point, try the decision, or if we have to um like that. Okay, if they say okay, maybe this host, okay, try to um getting access, they say okay, maybe that's not good, and then just rejecting from the decision point. Okay, so they say okay, and then the embedded switch, so the switch right here, we're telling okay, maybe you need to have some like virus, some malware scan, so before it connect, so it disconnect. So this one will be the PME, like I'm handling this part, and here's the idea it's going to do. And next, like how can we doing the detection about the network intrusion? So okay, so right here we have the NITI and the NIPIs. Okay, so will be the network intrusion detection system and then the prevention system. So mainly for detection, we will give an alert or some like notice of the network operation. Okay, like this. And then for the prevention, we try to stop the risk like from entering network. So all these like the possible like maybe related to our operating system itself, or sometimes the application or the application backdoor API, all this. Although we have some like let's say the buffer overflow. Okay, and of course like for example sometimes we have the cross site scripting, and also we have the remote access tool to provide a different all this. Okay, the intrusions right here. Okay, and this one we're talking for the two-way different. One is called the in-band. Okay, so they are in the within the one traffic flow. Okay, so they might be like travels like the IDS or IPS. Okay, some of them they are like out of band design, so they are not in the traffic flow. Okay, so they will try to copy each packet and send it to the IDS or IPS. So here will be like two different design. But okay, so in and out. Okay, so then we will like go into details, like somehow it's like inside. So our band response is like they are not inside the flow. Okay, so let's say if we have a device need to send the data out, and then so they are, since they are not in the traffic flow, so they will receive a copy of the package. Okay, so they will send the TCP RSD, so it's a reset to the host. So when the malicious traffic is fine, okay, so they will done after the fact or the UDP, so they have no reset, so they just like prevent some like timely response. So also it's possible. This is what the ISP should doing. So once it like let's say we have one host and then send it out to the switch. So because it's not inside, so the switch will send a copy to the package, and then the IPS will send a TCP to the host right here. Okay, that's what we say the after fact like that, or UDP and no reset. So right here in the middle, and we forward to the IPS, right? So IPS if we do find it, and we stop. Okay, and then and that's it. And for the in-band response, so it's because we put the ISP in this like network. Okay, so if the malicious traffic identified, then a package there is not allowed on the network, so they will just like queue at the IPS. So it's the idea from the internet, they go to the firewall or the IPS receive it, then we just like queue it. So and that's it. So once we like sending to the internet firewall IPS right here, once we detect it, and we just like queue it, and that's it. And for the IPS rules, so we have like they would determine the factual unwanted traffic, so including like block, allow, also like we will send alert. Okay, so they are all possible in doing different rules. Okay, so up different way to do handle it, and they may be like time consuming to manually create or maintain the rules, because it may be have some possible result. Let's say we have the false positive, or sometimes we have the false negative. Okay, like this, or they will disrupt of the service to user, and also sometimes they request like constant vigilance state to catch any new or emerging threats like this. So all these IPS rules like will maybe have some slow down the whole process, like because it consumes the time. And what some identification technologies included. So of course, like we have the rule base. Okay, really straightforward. We just like manually create a set of rules. Okay, so if some requires constant tweaking or updating. Okay, so easily update outdate. Okay, so that's why we have to like regularly update the rules. Okay, so maybe sometimes when we set up those rules, they require 1,000 of rules. So many. Okay, and then for another one will be the signature base. Okay, so we will use some predefined database. So of known attacks. So we have the signature. Okay, so if we try to scan the virus, we have some like signature. So we can evaluate those like possible attacks. So based on the matches. Okay, if we do find those signatures that match, then we can like reject. Also, they can request for this one for signature base, we can request the signature database to be updated. So it's like good because for like as good as like the last update, just update. Okay, so or we have more. Let's say we have the behavior and the normal base, just like not. It does not start with the signature database. So it just like establish like what like normal looks like. Okay, so once if there's any activity, say they are out of the norm. Okay, so they will maybe they suspect and then report it, or they try to learn. Okay, especially maybe we have some nowadays like we maybe implement with AI. Okay, so we can just like recognize it. So it can be more effective over time. Okay, quickly and easy to adapt to the change. And the benefits, we can consistently learning and evolving, so we can like improve like better and better. So we know, okay, so for some latest behavior, we after you learn it, then we know, okay, we can prevent it. Like compare with the rule base or signature base, we have update database. So this one will be better, like for the behavior base. Okay, and then well, also we have the heuristic base. So just like pretty similar to behavior or anomaly. So it just start with some like predefined signature first. Okay, and then we will dynamically like alter. Okay, alter the signature. So based on learned like what the normal looks like. So it's the same idea, and then we consistently like learning, evolving. So okay, so it's the idea. And there's some example that you can see right here. So if like we giving different type, like the thirst right here, so what the possible thirst in the we can search like when we receive the time, what's the new probability type, and then there's some like generic HTTP call sign scripting. If you remember one of the called the call sign we mentioned before. So it's like from where to where, and then what's the attacker IP address? Okay, so what's the victim's IP to which port? And then what's the application would be like we're browsing. Okay, so we just giving what kind of action, and then what's the security level. So like this, then we can detect all this. And we do mention the keywords. Okay, so the keywords we have, including the we call the like false positive. So what's the false positive? That means like the report is not really true. Okay, so we have the false alarm. Okay, and then mistaken identity. Okay, so suppose like false positive, that means it should be negative. Okay, but the system, the alert system like giving you is the positive. Okay, so this is false. Okay, maybe if you later you have an opportunity to touch on some research or doing something, so we will like compare. So okay, how many they are giving a false positive, how many are like false negative like this. Okay, so they are really too often, so they will cause a desensitization. So maybe like crying wolf or ignoring that alert. So all this maybe happened because the false positive. And after the false positive, we do have the false negative. Okay, so we just like misidentify something. So they should be catch, right? So some malicious traffic, they just like got through. Okay, suppose they shouldn't be passed through because we suppose it should be positive. We're just saying, okay, it's negative. So that's those alert our level that we is really dangerous because really hard to detect the false negative because it's silent because no alert. Okay, we don't know like what those things like went wrong. Okay, because we already thinking the system know. Okay, just label is a negative, but suppose they should be like positive. Okay, so they didn't catch it. Okay, so industry need to like provide some like catch or misread test so we can know. Okay, so how many false negative, then we can improve it. So here's the more like compared to false positive, we can still review those false positive and then convert them to negative. But for the false negative, because system let it pass through, then we have no way to catch it. So there's a huge difference between. We do have more like some like securing software, defining network, and kind of like it's including the software defined network. So we say it's the SDN. Okay, so the SDN, so for the networking device, they have two side of operation, including the control and data. Control is the for the management, and data will be the user data. Okay, with the edge, so it will change and then make it like really rapidly. So it's the idea for the software defined network. Okay, so for the SDN, so it can be centrally managed and then provide a global view so we can see it. So they're mainly configured by some program. Okay, we can do like program, particularly like doing okay. So we can orchestration or no human intervention. So right here, and also we can have some like open standards, render agnostic. So right here, we can giving some standard interface to the network. So this one is the software defined network. And here's the idea, just like pretty easy to reconfigure because they are all software security. So let's say we pass it and then we have the some virtual private network or some host nodes that pass through the firewall and internet. And once we need to change it, edit, so we can just add a key using mouse. Okay, so after we edit, we can move it like this. And when you need to change it at another firewall, isolate any nodes, okay, create another switch, VPN, so wherever you change, so you are easy to adopt it. Okay, so here's the network segmentation we're going to apply, and we will keep the next class will be a last class video, so it will be related to the zero trust architecture, and then for the rest, then we will complete our whole lectures, and we will finish right here, and thank you so much.